Hello students, good evening. Hope you can listen or hear to my voice properly, and also please let me know in your comment box whether I am audible and visible for you. So how's your preparation going? So I know that already you have completed your first sessions of your exams, right? And chemistry was one of the easiest paper. This year everything was direct, and the paper analysis, I have done a detailed paper analysis of the 12 papers that you have given in this year, right? We know that there were 12 sessions were there in 6 days, and I have given a detailed analysis of that 12 sessions, 12 question paper, full analysis, and you have to see that video. It's very important because I have cracked it down based on chapter wise, where you have to focus, which chapter you have to focus more for the next upcoming your JEE mains exam. Okay, and for your information, applications are open, registrations are open for the second this one, so you have to register it and you have to prepare accordingly. Okay, so it's very important. If you are a serious aspirant for JEE, please watch that video. Okay, I have broken it down into different aspects, and if you understand that analysis properly and if you can prepare accordingly, then obviously the second attempt of your JEE exam will be much more better than your first attempt. Okay students, so first of all, let me welcome you all to APJ Academy. Okay, now today we are going to discuss about the new topic in atomic structure. You know that which is the topic, right? You might have seen the thumbnail. We are going to discuss about the quantum numbers today. Okay, so before going into that, let's see some facts regarding APJ Academy, right? Okay, so this is our full year course. Okay, you can read it, what all things we are giving for you. Okay, there are PDF materials, there will be test series, and that will be 25 major test series you will be writing. See, practicing is the most important thing if you are preparing for a competitive exam, right? You know that just understanding the classes or just understanding the concepts is not enough. You also have to develop the analytical skill and the problem solving skill by doing more and more practice, or by doing more and more questions. By practicing more and more questions, you have to develop that mentality. Once you see the question, in a second you know the answer, right? You know the way, which way you have to approach that question. That can only be developed by practicing. So test series are very important. So we are providing 25 major test series, and that too in the NTA pattern. Okay, and you will be having the query solving, because in your long term preparation you will have lots and lots of doubts. If you are a student who wants to clear the concepts, then obviously doubts will arise, and doubt solving is a very important aspect of your preparation for any competitive exams, right? And we also have all the lessons, complete lessons with detailed concept clearance. Okay, we will give you the lessons in such a way that you can easily understand the in-depth concept of each chapter, each sections, and also you will have assignments, because assignments are very important in order to check yourself whether you have cleared all the concepts in that particular chapter, right? So these are the features of our full year course, and the most exciting feature is that this is given just for ₹490. Okay, that is 490 per month, right? And that's an enormous discount, and you can crack JEE or NEET with this much enormous discount. Okay, now if you are a new student to this channel, please subscribe, because this channel will surely add value to your preparation, because we are giving free classes, free content, and that too quality content freely through this channel. So you will not miss out anything if you subscribe. So subscribe to the channel, share the link with your friends, those who are preparing for JEE, as well as we have another channel called as NEET channel, APJ Academy's NEET channel. You can share the link of that channel also with your friends, those who are preparing for NEET. Okay. Now, okay students, are you ready? Let me ask this, are you ready? Okay. So today's lecture, and let me give a brief introduction about me. That's me. Okay. You can read what my credentials are. Just read it. That's more than enough. Okay. We have been seeing for the past 1 month, so you might know me well, right? So let's come to the topic, and today's topic is a beautiful topic, that is quantum numbers. See, let's start with the basics. What do you mean by quantum number? Actually, quantum numbers are those numbers which help us to identify, or which help us to understand or determine the position of an electron. See, we can take an analogy. What is an analogy? That is an address, your home address. So in your home address, I can send letters, and the postman will read the address, and they will come specifically to your house, and it will hand over the letter to you. And that's how we actually, it was in the previous decade, right? Nowadays we do not write letters, but in fact you might have known about that. So obviously we can take that example, and I can also give another example regarding which we can connect with the quantum numbers. Okay, so let's discuss about this. If I wanted to write a letter to my friend, and remember, or we will assume that there were no mobile phones as such in the modern days, right? So I wanted to write a postcard, or I write a letter to my friend. So what will be given in the friend? We will give the address of my friend, right? In order to deliver the letter to my friend, I need to give the address. So in the address, we can see there are majorly 4 things will be there. One will be the name of the person, right? Then there will be house name along with the locality. House name along with the locality. Then we will have district, name of the district. Then we will have name of the state, which state they live in. So these are the major 4 datas that is required for a person to send a letter to his friend, so that the letter will be properly handed over to his friend, right? So similarly, these 4 letters or these 4 datas are like quantum numbers if you are considering electrons. Okay, so first of all, let's take the state. In India, we know that there are numerous states, right? 29 states are there. It was 27 previously. Now 2 union territories have been converted to states. So 29 states, I think so. I'm not sure. So whatever. So in that, which state is this electron living? Say like that. We can take an analogy in that terms. We can say that they are living in my state. If you are considering me, then I can say I am living in Kerala. So among the 29 states, now we have decreased our focus to one particular state, and that is Kerala. In Kerala, we know that there are lots of districts. In any state, if you take UP, if you take Delhi, the Union Territory Delhi, or if you take Haryana, if you take Punjab, any state, there are lots of districts. So in Kerala, within the Kerala state, there are lots of districts. In that, my locality is in Calicut district. Okay, in Calicut there are lots of localities. So, and in those localities there are lots of houses. So I give the house name something X. Okay, and my locality also X. X is the house name and X is the locality. So it is specified. In my house or in my home, there are many members. But if you want to write a letter to me, you have to give my name. So you have to give my name. Okay, so these 4 datas will help you to send a letter to me, and that will be correctly handed over to me. This is how, this is in total, this is the locality where I live. So in order to identify the locality of an electron, we require 4 quantum numbers, which is analogous to state, district, house name, locality and name of that person. Is that clear, students? Please let me know in the comment section what I meant or what I said is clear for you. Okay. Now, a similar one, you can take another analogy, that is your Aadhaar card number. Aadhaar card number is unique number, unique ID number, which is only, which will be present only for one person. You cannot see one Aadhaar card number for 2 persons. No. One number is unique. That particular number is unique for a person. So if you type in any of the websites of the government officials, can take all the data regarding you. If you type in a particular software, if you type the Aadhaar card number of that person, you will get all the details of that person. That's how you locate that person, you identify that person. So similarly, like Aadhaar card number, electrons have quantum numbers, which have 4 quantum numbers, and that 4 quantum numbers are analogous to state, district, house name and name of the person. Okay, so let's discuss what they are. We have 4 quantum numbers, which helps us to find out the position or the location of the electron, which helps us to send a letter to electron, right? 4 quantum numbers. What are those 4 quantum numbers? 4 quantum numbers. One is principal quantum number, and principal quantum number is similar to the state, name of the state. Okay, so first we will identify the principal quantum number. Principal quantum number means that quantum number indicates in which shell the electron is present, in which shell or the orbit the electron is present. This is what the principal quantum number gives. So if the principal quantum number is 1, that means the electron is present in the first shell. Which is the first shell? First shell from the center of the nucleus. Okay, from nucleus we count the number of shells. So from the center of the nucleus we reach to the first shell. Then the second one is azimuthal quantum number. Second one is azimuthal quantum number. Azimuthal quantum number. So principal quantum number is indicated by the letter small n, and azimuthal quantum number is indicated by the letter small l. And azimuthal quantum number is analogous to district. Within the state we have lots of district. Similarly, within the principal quantum number, within the shell, not principal quantum, within the shell there are lots of subshells. What we have? We have subshells. Okay. So that is what it is, corresponds to district. Now the third one is magnetic quantum number. Magnetic quantum number. So in districts we have lots of localities or we have lots of houses. So magnetic quantum number is equivalent to localities or houses. It is generally denoted by M. So it is equivalent to houses or localities that can be called as orbitals. It is called as orbitals. Now the last one is spin quantum number. The fourth one is spin quantum number, and spin quantum number is analogous to the name of the person. Spin quantum number. So in one orbital, maximum of 2 electrons can occupy. Like orbital means it's a house. So in the case of the atomic houses or the orbitals, only 2 electrons can occupy. So the spin quantum number will only have 2 values. That is, it can have plus half or minus half. Here I can write spin quantum number is denoted by small letter s. So we can discuss this in detail. Okay, these are the 4 quantum numbers that help us to find the electron. Now let's discuss what is given in this. There are 4 numbers. These are the numbers which can determine the position of an electron in an atom. It can determine the position of an electron in a given atom. As I have told you, there are 4 numbers represented by n. N stands for principal quantum number, L stands for azimuthal quantum number, M stands for magnetic quantum number, and S stands for spin quantum number. And N, L and M are obtained by solving Schrodinger wave equation. So we do not require the Schrodinger wave equation. You just have to understand this. Now, principal quantum number, azimuthal quantum number and magnetic quantum number are obtained by solving Schrodinger wave equation. So these are the 4 quantum numbers which are required to determine the position of an electron in an atom. Okay. Now moving to the next one, we are here going to discuss about the principal quantum number. Okay. Principal quantum number, as I have told, it represents the number of orbit or shell or energy level. Okay. We normally use the term shell. The shell is also represented as orbit. Remember, it is orbit, not orbitals. Orbit is the term given by Bohr. Okay. Orbit is the term used by Bohr. So shell or orbit or energy level, anything you can represent. Okay. Anything, any name you can use out of these 3. So we generally use shell. Okay. So the principal quantum number gives the identification of a shell. It tells us about a particular electron present in which shell. Okay. So there are numerous shells. Okay. There are infinite number of shells, but we only have to study about 7 shells. Why 7 shells? Because we know that there are 118 elements known to us today, and these 118 elements have been present in 7 periods, and each period corresponds to each shell. So what does that mean? We only have those elements which have valence electrons present up to 7 shell. 8th shell electrons, the electrons present in the 8th shell elements are not discovered till now. So electrons, valence electrons which have occupied till 7th shell is discovered. So we only have to consider 7 periods or the 7 shells. Okay. So as I have told, first shell means that is the first shell from the nucleus. We have to number it from the nucleus. This is the first shell. And the second shell is the second shell from the nucleus. This is the second shell. So each shell can be represented with a letter. That is, first shell is generally denoted by K, second shell is generally denoted by L, third shell is denoted by M, fourth shell is denoted by N, and fifth shell is denoted by N, sixth shell is denoted by O, and seventh shell is denoted by P. So K, L, M, N, O, P, 4, O. Here I have represented 2 times, right? Let me remove this. Okay. So 5th shell is O, 6th shell is P, and 7th shell is Q. So there are normally we consider 7 shells. The reason I have already told you. Now, maximum number of electron in a given shell. What is the formula to find out? That is 2n square. So what is n? N is the number of shell, or it is the principal quantum number. If we are discussing about the first shell, if I am considering the first shell, the maximum number of electron that can be occupied in the first shell is equal to 2n square. That means 2 into 1 square, that is equal to 2. If I take the shell number 2, second shell, then the maximum number of electrons will be equal to n into 2 into 2 square, that is equal to 4 into 2. 8 electrons can be occupied in the second shell. If I am considering about the third shell, then the total number of electrons that can be occupied is equal to 2 into 3 square, that is equal to 18 electrons. And for n equal to 4, we have 2 into 4 square, that is in total 16 into 2, 32 electrons. This is how we calculate the total maximum number of electrons present in a shell. Hi Lakshya Bansal, how are you? How's your preparation going? Hope everything is going fine. Okay, and I hope you are enjoying the classes too. Right, now we are going to discuss about, now I hope this is clear for you. If we are considering the number of shells, if you want to know the maximum number of electrons in each shell, just use this formula, that is maximum number of electron in a given shell equal to 2n square. For first shell you can give the value n equal to 1, second shell you can give the value n equal to 2, third shell you can give the value n equal to 3, likewise it goes. Okay. Now the second one is maximum number of orbitals in a given shell. How we are going to find the maximum number of orbitals? Maximum number of orbitals in a given shell. What do you mean by orbitals actually? See, you will get a clear concept about orbitals a bit later. Okay, please wait until we cover the subshell topic. I'll explain, or I'll give you a detailed description on what do you mean by orbitals, or I can just give a hint over here. Just I'll tell that. Okay. Now, or else let's discuss in the next slide. That's better. So just remember this: maximum number of orbitals in a given shell is equal to n square. This formula, you just remember it for time being. Okay. In the next slide, we will be discussing about that in detail. So if n is equal to 1, then how many maximum orbitals are present? 1 square, that is 1. If n equal to 2, maximum number of orbitals present will be 4. If n equal to 3, maximum number of electrons present in the orbital is 3 square, that is 9. And in each orbital means, you know that it is like homes or rooms. Okay, orbitals is similar to the homes or the rooms where the electron lives. So one orbital can have a maximum of 2 electrons. So if you multiply, if one orbital is present, then if you multiply it with 2, you get the maximum electrons, that is 2 electrons. Similarly, if you multiply it with 2, you get 8 electron here. If you multiply with 2, you will get 18 electron here. Right? That is what we have just discussed in this equation. That is n square into 2 will give you the maximum number of electrons. Simply n square will only give you the maximum number of orbitals in a shell. But if you multiply that value with 2, because why I have to multiply with 2? Because one orbital can occupy 2 electrons. Okay. So maximum electron in an orbital is 2, that I have already discussed. Okay. In each orbital only 2 electrons can be occupied. Now what do you mean by angular momentum? That we have discussed in the Bohr's concept, that the electrons revolve around the nucleus, right, in a circular path. So obviously the electron will have what? Will have angular momentum, and that angular momentum will be equal to nh by 2 pi. So these are the facts you have to learn from this particular topic, principal quantum number. Let us move into the next one, that is azimuthal quantum number. See students, if you are considering the first shell, that is n equal to 1, understand this: if n is equal to 1, that is in the first shell, then the first shell can only contain one subshell. Okay, the second shell can contain 2 subshells. N equal to 1, that is the first shell. If the shell number is 1, it can only contain one subshell. If n is equal to 2, that is you are talking about the second shell, then that particular second shell can contain 2 subshells. If n is equal to 3, then that particular shell can contain 3 subshell. Likewise it goes. You might have got the equation here, right? So if n is equal to 1, then 1 subshell. So if n is equal to 1, we know that there are 4 subshells you have to study. What are they? S subshell, P subshell, D subshell and F subshell. 4 subshells. So it is denoted by the letter L. If the value of L is equal to 0, it indicates S subshell. If the value is L equal to 1, then it indicates P subshell. If the value of L is equal to 2, it indicates D subshell. And if the value L is equal to 3, it indicates F subshell. So L equal to 0 corresponds to S subshell, L equal to 1 corresponds to P subshell, L equal to 2 corresponds to D subshell, and L equal to 3 corresponds to F subshell. So where can I see this? See, first you will identify the shell. If it is the first shell, then in the first shell only one subshell is possible, and that subshell will be S subshell. S subshell. That means if n equal to 1, then L equal to 0 will be present. What is L equal to 0? L equal to 0 indicates a S subshell. Okay. Now, if I am considering the second shell, you know that in second shell there will be two subshell. Which one will be that? L equal to 0 S subshell will be present, and L equal to 1 P subshell will be present. Because if we are discussing about the second shell, the second shell can occupy two subshell, and that is L equal to 0 and L equal to 1. In the case of third shell, we can have three subshell, that is L equal to 0, L equal to 1 and L equal to 2. That means S subshell, P subshell and D subshell. If n is equal to 4, then we can have 4 subshells, that is L equal to 0, L equal to 1, L equal to 2 and L equal to 3. That is S subshell, P subshell, D subshell and F subshell. Now here I wanted to discuss one more factor, that is orbitals. If you are considering about the S subshell only have one house or one room. Okay. For this is S subshell. In S subshell, the orbital is like this. Only one orbital is present in S subshell. But if you are discussing or considering about P subshell, it have three orbitals, three boxes or three rooms. If you are talking about D subshell, it have 5 rooms or 5 houses. Okay. If you are talking about F subshell, it have 7 rooms, or you can say 7 houses. 1, 2, 3, 4, 5, 7. This is what basically you have to understand. Now, we have discussed about the principal quantum number. Principal quantum number is the number of shells in which shell the electron lies. Okay. If the principal quantum number is equal to 1, if the shell number equal to 1, that particular shell will only have one subshell, and the value of that one subshell will be one less than the principal quantum number. That is, if n is equal to 1, then L can only have one value, that is equal to 0. If n is equal to 2, then L can have two values, that is one is L equal to 0 and L equal to 1. That means S subshell and P subshell. That means the L value, the maximum value of L will be equal to n minus 1. The maximum value of L will be equal to n minus 1, one less than the number of shell. Okay. It only the value of L. Okay. If the shell number is 2, then obviously there will be 2 subshells. If you are considering about the third shell, in third shell we can have 3 subshells. What are their values? L equal to 0, L equal to 1 and L equal to 2. It stops at the value n minus 1. If you are considering about the fourth shell, you can have 4 subshells, that is L equal to 0, 1, 2 and 3. Okay. So, this is called as, this box, each box is called as orbitals. Each box is called as orbitals. If you are having only one orbital, that orbital is denoted by the magnetic quantum number m equal to 0. Okay, because if you have more than one, then obviously we have to identify in which orbital or in which room the electron is present, so that we have to use magnetic quantum number. Take the example of p orbital. In p orbital we have 3 orbitals, p subshell we have 3 orbitals. I do not know. If that orbital is not named properly, I cannot understand in which orbital my electron is present. So we give the center one is given as 0, m equal to 0. The left one will be m equal to minus 1 and the right one will be given as plus 1. So this is how we identify which orbital our electron is present. So in the d orbital, d subshell, we have 5 orbitals. Now the center one is marked as 0, left one is minus 1, the second left one is minus 2, right one is denoted as plus 1 and the second right one is plus 2. Similarly for the F subshell, the center one we give it as 0, left one, minus 2 and minus 3, and right orbitals is given as plus 1, plus 2 and plus 3. Now we can easily identify in which orbital our electron is present. Okay, that's why we use the magnetic quantum number. Hope this is clear, students. And one more fact is that in each orbital a maximum of 2 electrons can be present. So if I am talking about S subshell, the maximum number of electrons can be occupied is 2. If I am talking about P subshell, the maximum number of electrons is equal to 6. Because why 6? Because P subshell have 3 p orbitals and each orbital can accommodate 2 electrons. So 3 orbitals into each one carrying 2 electrons, that is 3 into 2, 6 electrons can be occupied. Maximum of 6 electrons can be occupied. Now if you are discussing about D subshell have 5 orbitals and each orbital can accommodate a maximum of 2 electrons. So total of 10 electrons can be accommodated in D subshell. So 2, 4, 6, 8, 10. Similarly, in the case of F subshell, there are 7 orbitals and each orbital can occupy a maximum of 2 electrons. So in the F subshell, we can have a maximum of 14 electrons. 14 electrons. Now let's move on to the third one, that is magnetic quantum number. A magnetic quantum number. Okay. Before that, maximum electron in a given subshell is equal to 2 into 12 plus 1. See, you already now know S subshell has 1 orbital, right? 1 orbital. So what is the maximum number of electrons occupied in S subshell? 2 electrons, since it has 1 orbital. Now P subshell have, we know that there are 3 orbitals present. And each orbital can have 2 electrons, that means maximum of 6 electrons can be present in that. And D subshell have 5 orbitals or 5 rooms and each room can accommodate 2 electrons, that means a total of 10 electrons can be accommodated. So what's the difference between subshell and shell? See, Naren Prashant, subshell means, shell means it's the outermost place. Like I have given analogy in the first place, in the beginning of the this session I have given an example. See, Naren, can you tell me in which state you are living? Let's tell me in which state you live. Can you just give the comment in the comment box? Can you tell me which state you live in? For an example, if I say I am living in Kerala, right? I say I am living in Kerala. Where in Kerala? In Kerala there are lots of districts. Okay, there are lots of regions where people live. So that is classified as districts. So I say I live in Calicut district. So likewise, the electron have a state and electron have districts, and within the districts they have localities where they actually stay. Within the locality they have house where they live in. Okay, so the state corresponds to the shell. That means first we will identify the shell or the state where you live in, and within the shell there are districts. That is the subshell. Is that clear, Naren? Okay. So you have to listen to the class from the beginning, then only you can understand all these concepts. We have already very well explained what are shells, what are subshells, and within subshell what are orbitals. So in a state we have different number of districts, and that district is correspond to the subshell. Okay, if you wanted to find me, let me explain this in this manner. If Naren and Roshan are close friends and you live in Delhi, say you are living in Delhi and say I am living in Kerala. Okay, so you wanted to identify me, you wanted to write a letter to me, okay, or you wanted to present me something, say like that. What you will do? You will send it in my address. So first you have to locate my location, right? So in India we know that there are 29 states, and you will search. Okay, you will search where I am. So first you will search in which state I am living in. That is the first case we will check, right? Which state I am living. So you identify that yes, I am living in Kerala. Then the second thing you are going to look is in which district I am living. So first you have checked for the shell, you identified in which shell my electron is, whether it is in the first shell or in the second shell, third shell or fourth shell. Likewise, we check it and we got a particular shell, that is the state. In Kerala I am living. In a shell, there are different subshells where electrons live. Like in Kerala, there are lots of districts where people live. So now you started to looking for which district I actually live. Okay, there are 14 or some districts in Kerala. So you will start to look in which district I am living in. So you understood that I am living in Calicut. Likewise, if you check for the shell, in the shell there are number of subshells, that is S subshell, P subshell or D subshell, and from there you identify or you check in which shell I am, which subshell I am, then you fix it. Yes, I am living in P subshell. Say if I am living in P subshell, like I am living in Calicut district. Now in P subshell you wanted to search which house I am living in, which house I am living in. Okay, in that district, in that locality, you are now looking for which house I am living in, and that house corresponds to orbitals. In P subshell, we can have 3 houses. 3 houses are present. If you say in Calicut district, there are 3 houses. So in which house I am living? Okay, and that information is given by the magnetic quantum number or the orbitals, m equal to 0, m equal to +1 or m equal to -1. So 3 orbitals correspond to that particular fact. Now the last one is, you have to know my name. My name is Roshan. So you have to know my name in order for the postman to hand over your gift to me. So each electron will have their names. Each electron will have their names. So you have to give them their name. You have to provide the name so that the gift is, or you can particularly identify that person from that particular house. Say if I am living in m equal to 0, in m equal to 0 there will be 2 persons living. And which person is your friend? Then you have to give the name of that person so that you can identify or locate that person. I hope this is clear for you, Naren. If not, please let me know what your actual question is. Okay, right. So in F subshell we have 7 orbitals are present and each orbital carry 2 electrons. So a total of 14 electrons are present in the F subshell. So in S, P, D, F, this much. So let's see this. Maximum electron in a subshell can be, you can use this formula. Maximum electron in a given subshell, you can use this formula, or you can just give this values, guys. If it is F subshell, then S subshell it is 2 electron, P subshell 6 electron, D subshell 10 electron, and F subshell 14 electron. For the sake of doing it, just check the value. For S, if we are talking about S subshell, then the value of L is equal to 0. Then substitute the value L equal to 0 there. You will get 2 into 0 plus 1, that is equal to 2. That is the number of electron present here. Okay. Now for P, you can put the value for P, L is equal to 1. So substitute the value in the equation, that is 2 into 2 into 1 plus 1, that is 2 plus 3 into 2, that is 6 electrons. See, the same thing happens here. Now if you are talking about the maximum orbital in a given subshell, that also you know. For S subshell we have 1 orbital, for P subshell we have 3 orbitals, for D subshell we have 5 orbitals, for F subshell we have 7 orbitals. So 2L plus 1. For S subshell, how many orbitals? 2 into 0 plus 1, that means 1 orbital. For P subshell, 2 into 1, that is L equal to 1 is P, plus 1. So 2 into 1 plus 1, that is equal to 3. We know that P subshell has 3 orbitals. And for D subshell, 2 into 2 plus 1, that is equal to 5. And for F subshell, here you can see 5 orbitals. 2 into 3 plus 1, that is equal to 7. Is that clear, students? Hope it is clear for you, right? Now, let me explain this one more thing. See, for n is equal to 1, for n is equal to 1, we know that L can be 0. For n is equal to 1 means first shell, only one subshell is present and that subshell is L equal to 0. What is that? That is S orbital. How many electrons? Maximum 2 electrons. So here you can say number of number of subshell, maximum number of orbitals, and number of electrons, number of maximum electrons, and number of maximum orbitals. The equation is n square. Here the equation is 2n square, right? N square corresponds to, if n is equal to 1, the number of orbitals is 1 square, that is 1, and number of maximum electrons is 2 into 1 square, that is 2. Without that itself, we have written here 1 orbital and 2 electron. Without the formula, if you know the concept, then you can directly use it. If n is equal to 2, that means there can be 2 subshell. Which are they? One is L equal to 0, the other one is L is equal to 1. L equal to 0 means S subshell, there is only 1 orbital and 2 electrons in that. And for L equal to 1, it is P subshell, that means it consists of 3 orbitals. So for n equal to 2, how many orbitals are present? Total of 4 orbitals are present. So number of maximum orbitals is equal to 4. That means you can substitute the value 2 here, 2 square is equal to 4. And if you want to find the maximum number of electrons, 2, 4, 6, 8, you can write it as 8, right? Or you can use the formula 2 into 2 square, that will be equal to 8. Hope this is clear, students. If you are considering about n equal to 3, for n equal to 3, we can have 3 subshells, right? L equal to 0 can be present, L equal to 1 can be present, and L equal to 2 can be present. These 3 subshells are present in the shell 3. That is, for L equal to 0 means S orbital, 1 orbital, S subshell, 1 orbital, and P subshell, 3 orbitals, maximum of 6 electrons, and for D subshell, there are 5 orbitals. So 2, 4, 6, 8, and 10. So tell me the total number of orbitals present here. 5 plus 3 plus 1, 8 plus 1, 9. Or you can use the formula n square, put the value n equal to 3, 3 square equal to 9. Okay. Similarly, what is the maximum number of electrons present? 9 orbitals are there, each orbital carry 2 electrons, so total 18 electrons are present. Or you can use the formula 2n square. What is 2n square? 2 into 3 square. 2 into 3 square, that is 2 into 9, that is equal to 18. So this is the concept regarding the quantum numbers. Now we have to discuss about one more concept, that is a spin quantum number. Before going into that, let's discuss about the orbital angular momentum. See, in each orbit, the electron will revolve. Okay, electron is always revolving or rotating in its orbit, or it's in shell, it rotates. So what is the formula for that? The formula is root of L into L plus 1 h by 2 pi. So that is the formula for finding out the orbital angular momentum. Okay, for shell angular momentum, what is the angular momentum in a shell? That is nh by 2 pi. Don't forget that, that is nh by 2 pi for the shell angular momentum. Electron's angular momentum in a shell. In the orbit, it have some other value, that is root of L into L plus 1 h by 2 pi. That means you can replace this h by 2 pi by h bar. In some of the exams, they have used this h bar also. Okay, so don't get confused. H bar simply means h by 2 pi itself. So for what is the angular momentum of electron in s orbital? For s orbital, we know that L value equal to 0. So if you substitute the value 0 here, you will get the angular momentum also equal to 0. For p orbital, we know that L is equal to 1. That means the angular momentum will be root 2h by 2 pi. Okay, you can substitute the L value here. Now for D subshell, we know that L is equal to 2. That means 2 into 3, that is root 6 h by 2 pi. And for F, L is equal to 3. What is the angular momentum? Angular momentum is 3 into 3 plus 1, that is 12 root 12 h by 2 pi. Yes, hope this is clear, students. Let's move on to the next concept. Now here is the question. Orbital angular momentum of 2s, 3p, 4d and 4f. Here they have asked us about the orbital angular momentum. So we do not require these values. You know what is this value indicates? See, 2s means n is equal to 2. This 2 indicates the shell in which the electron is present. Actually, 2s means the s subshell present in the second shell. See, if I say 1s, 2s, 3s, likewise it says 1 indicates the s subshell present in the first shell, that is n equal to 1, and 2s indicates s subshell in the second shell, and 3s indicates s subshell in the third shell. So here they have asked about the orbital angular momentum. In orbital angular momentum, we only have to know the value of L, because L into L plus 1 h by 2 pi is the formula. So here we know that it is 0. And in the case of 3p, we know that p is equal to 1. So you can substitute the value 1 here for L. So you will get root 2h by 2 pi, root 2h by 2 pi. For 4d, you need not have to give the value 4 anywhere in the angular momentum, orbital angular momentum. For 4d, that means for d, L is equal to 2. So you can substitute that 2 here. 2 into 2 plus 1, 2 into 3, root 6 h by 2 pi. Now 4f is equal to 3 into 3 plus 1, 12, root 12 h by 2 pi, root 12 h by 2 pi. So these are the answers for the given question. Now let's discuss about the magnetic quantum number. Magnetic quantum number we have already discussed, but let me clear it out. I have told you that in each orbital a maximum of 2 electrons can be occupied. We denote it by this manner, 2 electrons. One pointing towards up and the other pointing towards down. What does that mean? See, in each orbital, electron will have 2 spins. One spin, that means it spins in its own axis, that it spins in the right or clockwise direction, or it spin with in anti-clockwise direction. So 2 spins we can identify. One spin is clockwise and the other spin is anti-clockwise. If an electron is having clockwise spin, we denote it by this is about magnetic quantum number. I was talking about the spin quantum number. Sorry for that. This already we have discussed, right? I forgot that. Okay. That is, magnetic quantum number gives the orientation of the orbitals. That is, for s subshell we know that there is only one orbital and that orbital is denoted as 0. For p subshell we know that there are 3 orbitals are present. So the middle one is represented as 0, left one is -1 and right one is +1. So normally we denote it as m can have values from -L to 0 to +L. That means if you are considering about p, what is the value of p? L value of p? L value of p is 1. So it can have -1, 0 and +1. 3 values. That's what we have given here. That is what this sentence or this point means. If I am discussing about d subshell, we know that for d subshell L is equal to 2. So in d subshell we know that there are 5 orbitals. So how many values it can have? It can have values from -2 to 0 and 0 to +2. That means the middle value will be 0, then left is -1, -2, +1, +2. This is what it means. Okay. Now for f subshell L is equal to 3. That means how many values can we have? -3 to 0 to +3. That means -3, -2, -3, -2, -1, 0, +1, +2 and +3. We know that for f subshell there are 7 orbitals, 1, 2, 3, 4, 5, 6 and 7. Center is 0, left -1, -2, -3, +1, +2 and +3. This is how we represent the orbitals, and for representing the orbitals we require magnetic quantum number. Okay, that's it. Now we are moving into the spin quantum number. I have told you for each orbital there are 2 electrons present, one having an up spin, the other having the down spin, or we represent the spin in this manner: electron spinning clockwise and electron spinning anti-clockwise, opposite to the clockwise direction. So this spin is denoted as, clockwise spin is denoted as +½ and anti-clockwise spin is denoted as -½. That is, the spin quantum number can have two values, that it can have either plus half or s can be minus half, no other values. If it is clockwise, we denote it by plus half, and if it is anti-clockwise, we denote it as minus half. I have told you, in a house of electrons, there can be possibly 2 electrons can occupy, maximum of 2 electrons. So in my house, if you are talking in terms of electrons, in my house there can only occupy 2 persons. One is me, the other is someone. Okay, and if you are my friend and if you want to send some gift to me, you have to write my name. Okay, otherwise the postman get confused, or the courier boy will get confused to whom they have to give this. So when you reach my home, when you reach the orbital, you have to give the proper name in order to make it clear that to which person you have sending the gift. Likewise, if you have reached to the orbital, no Raghav, no, I leave cheyiditilla. Okay, I'm still there. Don't worry. Okay, so here we have 2 spins, that is one spin is minus half and the other spin is plus half. Okay, that's what. Raghav, I'm still there in Salem, don't worry. Okay. Okay, now we have 2 spins in the case of one orbital. If you are considering one orbital, you have 2 spins. So one is we have one spin is clockwise, the other spin is anti-clockwise. Okay, and you know that spin angular momentum, and for each spin we know that in the case of electron we have spin angular momentum, and what is the formula of spin angular momentum? That is root of s into s plus 1. So it can have, s can have 2 values, either plus half or s can have another value minus half. Agni batchil undu njan. Okay, we can make it, don't worry. S is equal to plus half and s is equal to minus half, and you can substitute the value of plus half or minus half, you will get the spin angular momentum, right? Okay. Now write all the 4 quantum numbers for 4p orbital. 4p orbital, in 4p orbital, what are the 4 quantum numbers? As I have told you that 4 indicates the number of shell. So first the principal quantum number you have to write. We know that there are 4 quantum numbers, that is n, l, m and s. Okay, so what is n? N is the number of shell, that is n is equal to 4. And what is l? Obviously we know that if n is equal to 4, then l can have 4 values, that is l can have 0, l can have 1, l can be 2 and l can be 3. But here they have clearly mentioned that it is p. So if it is p, then what will be the value? We know L equal to 0 stands for S subshell, L equal to 1 stands for P subshell. So here L is equal to 1. So N equal to 4 and L equal to 1. Now we know that for P there are 3 orbitals present. What are the possible values of M? 0, minus 1 and plus 1. So I can give it as M can be minus 1, 0 or plus 1. And for S, S can have 2 values, plus half or minus half. These are the 2 values possible for the spin quantum number. Okay. So these values, N equal to 4, L equal to 1, M equal to minus 1, 0 plus 1 and S equal to plus half and minus half. These are the 4 values, N, L, M and S. These are the 4 quantum numbers, right? Now calculate all 4 quantum numbers for the last electron of rubidium Z equal to 37. See students, here in the case of rubidium, you have to understand the periodic table well. We know that rubidium is the element that is present in the first group, that is it is present in the s orbital or the s block element. So in s block element we know that lithium, sodium, potassium and rubidium. Okay. Now lithium is present in the second period sodium is present in the third period, potassium is present in the fourth, and rubidium is present in the fifth. And these elements are present in the first group. First group means it have the configuration of S1. So this have the configuration 2S1, this have the configuration 3S1, this have the configuration 4S1, and rubidium have the configuration 5S1. That is the valence electronic configuration is what I am telling. Okay, so the valence electronic configuration of rubidium is 5S1. Valence electronic configuration of rubidium is 5S1. Sir, 75% rule for 2023. Notorious, I didn't get you. What are you speaking? For JEE, 75% rule. 2023, 75% rule. I didn't get you. What actually you are telling? Please make it clear so that if you are asking about any guidance, so that I can give it now. Okay, please make it clear. So 5S1 means you have to write all the 4 quantum numbers. No, now we know that n is equal to 5. That is the first quantum number. Now the second one is L equal to 0. Since it is S, we can write it as L equal to 0. Now for L equal to 0, they can only have one magnetic quantum number, that is M equal to 0, since S subshell only have one orbital, and S can have either plus half or minus half. We need 75% in boards. Okay, you have 72. In 2023, oh, okay. So is it a valid information that you are telling? Normally it was. Should I repeat JEE? See, first of all, you have to wait for the NTA new circular regarding whether they have changed the percentage to 75 or not. Okay. See, I don't think that they will make, because 60% was the benchmark that they have kept, and I don't think that they will change it. If any official circular has come, then only we can confirm it. Okay. As far as I know, till now, there have no official confirmation regarding the 75% is given. Okay. If that is not the case, I believe you can repeat for JEE. You have to go for JEE repetition. Okay. If you haven't scored good marks, we can give you the proper guidance how you can crack JEE, even the mains as well as advanced. Okay. So don't worry about that. Let's wait for the official announcement of NTA if there is any changes regarding the percentage for the 12th boards. So as far as you can just look in for the new any further updates from NTA, just look into that, confirm whether there is such an update is present or not. If that is there, if in case, I'm telling, if in case if 75% is they have updated the mark to 75%, if that is the case, you can do one thing, that is, if you can give an improvement examination for the +2, okay, your 12th board, if you can appear again, and you can, if there is a possibility that you can improve your mark, you have to think about that also. Okay, you can improve only 3% now. So you can just write the improvement exam and score good marks, and your percentage will get improved. Okay, so don't worry. Let's wait for the official announcement. If there is any changes regarding that, then you can think about whether you have to repeat or you have to go for any improvement exam. Okay, HSC, not CBSE. Yes, I'm talking about HSC itself. Don't worry about that. Whether it's CBSE or HSC, that's not a big deal. Okay, both are same. Now, and this is all about this question. I hope this is clear for you, and we have discussed all the 4 quantum numbers in detail, and I hope everything is clear for you. And if it is clear, please let me know in the comment section. Okay, you can give your comments on this video, and please let me know it is clear for you or not. Okay, students, and I hope everything is clear and your preparation is going well. And I again want to remind you, I have done a video on the analysis of 2022 JEE mains paper. I have analyzed all the 12 papers and have given the crystal clear information on which topic you have to specifically study or you have to focus for the upcoming JEE mains exam. So don't miss out that video. It's a 27-minute lengthy video, but it is worth watching because it will give you a crystal clear picture on how from here to the next JEE mains exam, how you have to prepare that. I believe that you might have registered for the second JEE exam, mains exam. So how you have to prepare, you will get a clear-cut picture from that video. So don't miss out that video. Hope everything is clear for you guys. So let's meet in the next class. Thank you for watching. All the best for your upcoming JEE mains. Thanks a lot.